All right, pre-cal students, this is the Unit 3 Quiz 2 review. So let's go and get started. All right, so given the given point, question number 1 on the terminal side, find the value of the trig function. All right, first off, we have to draw everything so we can kind of visualize what's going on here. So here's my crosshairs here. All right, it says 28, negative 45. So 28, negative 45 would be in quadrant 4. So a triangle will be drawn to that point and back. All right. So if you remember the cosecant, remember cosecant is, well, that's what we're trying to find. So first off, let's go ahead and label everything. We got 28, we have negative 45. All right. So we need to find our hypotenuse, which means we're going to do the Pythagorean theorem. So 28 squared plus negative 45 squared is equal to c squared. And I'm going to kind of speed up. So hopefully at this point you should know how to do the Pythagorean theorem. If not, make sure you see your teacher. The answer is 53. All right. So now that we have all three sides drawn, then it's time to actually solve, which is the cosecant. Now remember, the cosecant is the opposite of sine. So sine is opposite over hypotenuse. However, cosecant would be the hypotenuse over the opposite. So remember, the hypotenuse is always the diagonal here, and the opposite, remember the origin, that is your point of reference, so the opposite is going to be negative 45. So that means our final answer is going to be negative 53 over 45. Pretty simple. All right, question number 2. We're again doing the same exact thing, except now we're going to be in quadrant 1 because they're both positive. So that's going to be 6, 12. I'm just going to guesstimate and say that's where it's going to be. So now drawing my triangle like so, labeling accordingly, I'm at 6, 12. All right. Again, I got to find what my hypotenuse is. Now, the reason why this one is so special is because I specifically made it to where it's not going to be a perfect square. So let's see, 6 squared plus 12 squared is equal to c squared. That ends up being 180 is equal to c squared, which means I need to do the radical of 180. So the square root of 180. All right, so at this point, you should know how to do this. Two numbers that multiply to get to 180. Let's just go ahead and do it the long way. We're going to do 2 and 90. Again, 2 and 45. 45 is not a prime number. That becomes a 9 and a 5. And we're continuing. 3 and 3. There we go. Those are all my prime numbers. A 2, a 2, a 3, and a 5. All right, so let me kind of clean up some space so we can kind of write. I'm going to go ahead and list them from a just organization perspective. 2 times 2 times 3 times 3 times 5. Now this is my working answer. Remember, the rule is whenever you're able to make a pair, you put one on the outside. So a pair of 2s, a pair of 3s. Anything that's a singleton goes inside the radical. So I'm going to multiply 3 times 2, and I get 6 radical 5. So that is my new hypotenuse, 6 radical 5. So now that we have all three sides, we are going to go ahead and do sine. Now remember, sine is opposite over hypotenuse, all right? So the opposite actually was 12. I lost. There it is. There's 12. Got erased. So it's going to be 12 over 6 radical 5, okay? Now at this point, we have 12 over 6. That can be reduced. When you divide by 6, that becomes 2 over radical 5. A radical in the denominator is a no-no, so we're going to multiply at the top and bottom of radical 5. And my final answer is 2 radical 5 over whole 5. There we go. All right, question number 2. We're dealing with a negative 105. Now, a negative 105, let's go ahead and just convert that to any degree that is in the 0 to 360 range. It just makes life a lot easier. So I'm going to add 360 to it, and I end up with 255 degrees. All right. So two numbers that multiply to get to 255. I'm going to go ahead and just choose. It's going to be the cosine, and I'm going to do cosine 135 plus 120. Now this is going to be my A. This is going to be my B. Remember, the cosine addition is cosine A, cosine B, minus sine A, sine B. All right. So again, you're going to the unit circle, and I do not have one, so I'm hoping that you have one in front of you right now. So cosine of A, which is 135. I guess I should have wrote it cosine of 135, but I didn't. My fault. Radical 2 over 2 times cosine of B, which is 120, is negative 1 half, minus sine of A, which is radical 2 over 2, because that's 135, and then sine of 120, which is radical 3 over 2. All right? So do the math. That gives me a positive radical 2 over 4 minus a radical 6 over 4. Now, of course, you could rewrite this under one as one denominator, or under one over one denominator. I get it right. There we go. There's my answer. All right. Now for our next one here, very, very similar. In fact, I'm just going to go ahead and write it out without really explaining it. So hopefully you guys can get this. I'm just trying to save a little bit of time. First off, you're dealing with radians. I don't necessarily love radians, so I'm going to go ahead and convert it to a degree, which by doing the whole 180 over pi, when you do the math, you end up with 75 degrees. All right, so it ends up being sine, and I'm just going to go ahead and add 45 plus 30. This is my A, this is my B. So that means it's going to be cosine 45 and then uh, sine, and I'm running out of room, sine 30. All right, so it ends up being right. I said I wasn't going to talk, and here I am talking. Again, pulling all these numbers from the unit circle, radical 6 over 4 plus radical 2 over 4. So my final answer would have been radical 6 plus radical 2 over 4. There we go. All right, question number 3. All right, now question number 3, you're actually working backwards. So going back to question number 2, if you notice, you actually had to create the identity, kind of expanded. Here, the identity has already been expanded. So what you've got to do is figure out, okay, is that, what identity is this? Is it going to be like cosine A minus B? Is it cosine A plus B? Is it sine A plus B? Or is it sine A minus B? And you have your formulas with you, so you should be able to figure that out by looking at how everything is kind of set up. So what we have is cosine, cosine, addition, sine, sine. Well, if you have your formula sheet in front of you, that is going to be cosine with a subtraction kicker. All right. So we have one negative 10 theta as A, and this is B. All right, so very simply, I'm just going to substitute. I'm going to take negative 10, plug it in for where A is, and then take positive 12 theta in for B. So here we go. Cosine is negative 10 theta minus 12 theta. Do the math. My final answer is cosine negative 22 negative 22 theta. There we go. Same concept for the next one. I'm going to go ahead and speed up just for time's sake, and that is we need to, again, determine what it is. And because it's sine, cosine, plus cosine, sine, that is going to be a sine A plus B situation. So this is my A, this is my B. So again, substituting here, substituting that, it becomes sine 2 over 5x plus 3 over 4x. Now, you can either do this with your calculator, do the old-fashioned way. I'm going to go ahead and do the old-fashioned way with common denominators. My common denominator would be 20, so I'm going to multiply this one by 4. This one, that's a 4, even though it looks like a y, times 5. It ends up being 8 over 20x plus 15 over 20x. You do the math, and you're left with my final answer being 23 over 20x. Technically, I guess you could say it would be sine 23 20x. All right, next one. Verify each identity. So if you remember in class, I told you anything that is not sine or cosine, convert it. So secant will be 1 over cosine times sine over 1 times cosine. It's already over 1. All right, do the math. And what happens is your cosines cancel out, and all you're left with, I mean, technically, I guess you can say your 1's cancel out too, and your final answer is sine. All right, next one. Again, sine and cosine. And for folks that are in Miss Vitrano's watching, very rarely do I ever put X or anything just because I just don't want to. All right, 1 over cosine. All right, so you do the math. One of the signs cancels out one. Now remember, sine squared is like saying sine sine. All right, so one of them got canceled out, but it's still sine left. All right, so when you multiply it straight across, it becomes sine over cosine, which ends up being tan. There we go. All right, next one is a Pythagorean identity. All right, so a Pythagorean identity right here, as well as in the denominator. All right, so we've got Pythagorean identities all over the place. All right, so 1 minus sine squared, um, you do have your formula sheet in front of you. I'm just going to, hopefully you might need to ask me or Ms. Vetrano when you see this, but 1 minus sine squared, the identity that we're going to be using, sorry, I had to grab a paper here, is going to be sine squared plus cosine squared is equal to 1. All right, so when you move things around, like if I move the sine over here, it becomes cosine squared is equal to 1 minus sine squared. And if you notice, that is a match, 1 minus sine squared. So that means my numerator is going to be cosine squared over, same concept underneath, it ends up being, let's see, I'm kind of clean up a little bit here. The Pythagorean identity we're going to use is going to be 1 plus cotangent squared is equal to cosecant squared. All right, so when I move the 1 over, here, it becomes minus 1, which means the bottom is cotangent squared. All right, so that's our first step. We got to keep going. All right, so it'll be cosine squared over cotangent, which is cosine squared over sine squared. Well, you're dividing by a fraction, so that's going to be a keep change flip. So cosine over 1 times sine squared over cosine squared. All right. That cancels that out, and I'm left with sine squared over 1, which is sine squared. There you go. Pretty simple, hopefully. Wrong button. All right, next one, use sum and difference formulas, find the following. All right, so what we got is triangles. All right, it says we're in quadrant 2, so I'm going to go ahead and draw a default triangle in quadrant 2. All right, remember cotangent, that is your x over your y, so that's going to be negative 12 over 35. I'm going to go ahead and label this triangle A, and it ends up being my hypotenuse 37 when I do the Pythagorean theorem. My next one is a triangle that is in quadrant 3. There we go. All right. Again, sine is opposite over hypotenuse. Make sure you honor the negatives here. So when I do the Pythagorean theorem, this ends up being 21. However, a reality check says that should be negative 21. So make sure you don't mess up on that. Cosine. All right, so cosine, that's going to be cosine A, cosine B, plus sine A, sine B. All right, first thing out of the gate is cosine A. So remember, cosine A is, using the A triangle, 12 over 37, or negative 12, sorry, negative 12 over 37, times cosine of B, which is negative 21 over 29, negative 21 over 29. We're going to add that to sine of A, which is 35 over 37, 35 over 37, and then sine of B, which is negative 20 and 29, negative 20 over 29. All right, So you can either plug all this into your calculator or do it the old-fashioned way. The old-fashioned way is, remember, numerator times numerator, denominator times denominator. You get 252 over 1073 plus, that'll be negative 700 over 1073. Final answer is going to be negative 448 over 1073. Here's your final exact value. All right, next one. We are in not cosine, but first quadrant. I'm just going to draw like this. Remember, your cosine is going to be your adjacent over your hypotenuse. So adjacent is 40, hypotenuse is 41. The Pythagorean theorem says that this is going to be 9. I'm going to call this A. Next triangle is in quadrant 4, which is right here. And a tangent, remember, tangent is x over y. Scratch that. Y over x, y over x. So let's make sure we honor the positive and negatives. So that's going to be positive 112, and this will be negative 15 because I'm going down. All right, and so Pythagorean theorem, this is going to be 113. So we're trying to find sine, so that's going to be sine of A cosine of B plus sine of, cosine of A sine of B. All right, so I'm going to go ahead and speed up. That'll be 9 over 41 times 112 over 113 plus 40 over 41 times negative 15 over 113. Again, if you multiply these two pairs, you get 1008 over 4633 plus negative 600 over 4633. Final answer, 408 over 4633. All right, so write a sine equation with the given information. All right, so what we're given is max and minimum. Now remember, guys, your sine function is going to kind of look like that, right? So the very top is 36. The very bottom of the graph is 16. So right in the middle is where our midline would be. All right, so add 16 and 36 together and just average the two, and you end up with 26. That is where that's going to go. Remember, the amplitude is the distance from the midline up or the midline down, depending on how you want to look at it, and that's going to be 10. All right, now in order to find B, remember, find B is 2 pi over the period. Well, the period is pi over 6, so pi over 6, so that we're dividing by a fraction, so keep, change, flip. That would be 2 over 1 times 6 over pi. Pi's cancel out, and we're left with 12. Our B value is 12. Next is finding our C. Finding your C is probably the most challenging because you got to do a little bit more math, all right? Now remember, finding C, you got to use the phase shift formula, which is negative C over B. Phase shift is right there, so 2 pi over 5 is equal to negative C over our B, which is 12. Okay, so a little bit of algebra. You are going to multiply 12, get it out of the denominator, multiply 12. So that'd be 12 over 1 times 2 pi over 5. You do the math, you get 24 pi over 5. However, if you notice that C is negative, so you got to multiply by negative 1 or divide by negative 1. That'll give your answer 24, negative 24 pi over 5. Pretty simple. All right, for our next one here, I'm going to recycle our picture from the previous question. All right, clean all that up. Now, we have a max of 10. Oh, look at that. Our minimum is negative 24. All right, so what is our middle number? Well, again, add these two together and divide by 2. So 10 plus negative 24, and then divide by 2, and you would get negative 7. All right, so that means the midline's at negative 7. All right, so next the question is, well, what's your amplitude? Well, the amplitude, again, is negative 7 to positive 10 or negative 24, whatever you want to do, and our amplitude is going to be 17. Now, you might be asking, why isn't it negative? Well, I'm assuming everything's positive here. You know, it's not a reflective curve. And I know, Miss Vetrana, you do like the plus and minus thing. So my students, we don't kind of do that. So it's all right. All right, moving on. Finding our b value is going to be 2 pi over our period, which is 4 pi over 3. So 2 pi over 1, keep change flip, 3 over 4 pi. You do the math, you get 6 pi over 4 pi. Pi's go away, and then I'm left with 3 over 2. That's my b value, 3 over 2. All right, so phase shift formula, remember the phase shift is equal to negative c over b. So my phase shift is 5 pi over 4 is equal to negative c over b, which is 3 over 2. Remember, you got to multiply 3 over 2 to get it out of the denominator. Don't keep change flip. I know some of you guys are going to do that. So when you do the math, it ends up being 15 pi over 8. But remember, it's equal to negative c, so that means divide by negative 1, and there we go. So negative 15 pi over 8. There you go. All right. Hope that all made sense, and I don't think I made a mistake, so if I did, I'm sure you'll definitely let me know by the time, well, already by now. Anyway, let me know if you have any questions. Take care.